Hello there, this is Brenda Cherano and welcome to this video on access control list. And the access control list I'm using is the standard numbered access control list. So yeah, a standard numbered ACL. As you can see here, I've already pre-drawn the topology. So these two routers are connected using a serial cable. And in this first router, there is this network here, the 192.168.1.0, and in the other router, there are two networks that are connected to it, the .2 network and .3 network. So what I need to do right now is first know that this is a standard access list. So the access list is actually filtered at layer 3 using the source IP address only. So, and then also as a standard numbered access list, it should be applied as closest to the destination as possible. So if the destination for here, if this one wants to reach this other router here, say this router is where? This is maybe in a building somewhere, say in a city called City A. This is a City A. So this other one here is City B. Yes. So and these two need to communicate each other, and they are in different cities, but they are one in the same organization. So for A to reach B, they have to have a communication. To do that, we have to first configure IP addresses for these interfaces so that they can be up and running. So to do that, I'm going to configure the router first. So this router, I'm going to name it router hostname is going to be R1. So first and foremost, I'm going to have an interface. Of course, I'm starting with the gigabit interface for the inside network. So IP address is 192.168.1.1.55.55.25/25, which is 128. Yes, no shutdown. Perfect. So we go back to the next interface, which is a serial interface 0/1/0. Yep, /0. So IP address is 172.16.1. I'm going to give it a .1 also, 255.55.255. This is a /26. That's a 192. Perfect. And then no shut there. So you're done with that. We come to the next network here, and of course the same thing here. I'm going to configure the interfaces. I'm going to call it actually. So yeah. These are the two network. Or the 2.1. Perfect. So on the next interface is 0/1. The 3.1. So 55.55.192. No shut there. Perfect. So we come to the next interface. That's the serial interface. Interface S0/1/0. So the IP address here is it's 172.16.1.2 255.255 and then /16 192. Yeah. Oh my goodness, actually this is so wrong. This is 192. Also this one is going to be 192. Okay, I think we can change that down. Since I've configured this one I configured it as 192 also. So 26, I'll just change here to be 26. Yeah, also is 26. Yep, perfect. So I've configured everything and everything is up and okay. So yes, so since everything is okay, also in the IP configuration I'll have also to configure the IP address of this PC. So I'll give it a 192.168.1.2. Since it's a /26, it's a 192. And then now here 192.168.1.1. Perfect. So the next one for this other network is this 192.168.2.2. I think that is okay. And 192. Okay, 192.168.2.1. Perfect, that's okay too. So this other one is also going to be having an IP address 168.3.3 or maybe .2, and this one is 192. And then here 192.168.3.1. Perfect. So everything is all up. Every device here has an IP address. So right now, as you can see, everything is okay. So if I try to ping, for example, to the next network, which is ping, say 192.168.3.2, it's unreachable because there's no route to that other network. So what I do here in this network is to have a static default route. So to do that is to just say route, say IP route, and then the default is 000, and then 0000, and then the serial is the one that is going to reach the other side. Perfect. So since this one is a point-to-point interface, I'm going to use this serial number. The same thing happens here. Exit interface. No, I'm going to say IP route. Yeah, 0.0.0.0. 0.0.0.0. Same thing, zero. Perfect. So as everything now, since I have a route that can reach here and here, the static default route, I can try and ping from this router here. I can ping 192. No, let's just see first the route. Do show IP route and check if it's there. Yeah, the static route is over there, so it's directly connected to that serial. So let me ping, say, from this router here, I try pinging this PC here. So what I do is to say I do ping 192.168.3.2. Yeah, exactly. So it is reachable. So the route is working and everything is all good and fine. So what I do now is to now come in and start with the access control lists. So since this network can reach the other network, they can ping, I can now control the networks that can reach these other networks over here and vice versa. So what I do, I would want in these routers, this one is R1 and this one is R2. So in this R1 over here, I'd want to create a standard numbered access list so that it can prevent a traffic from this network here or from this one. So I'll choose to prevent the traffic from the .2 network from reaching this other network over here. So this is where the access control list comes into place. So first and foremost, what I'm going to do is to create access list here. So to do that, I'm going to say access list. So this is a standard ACL, which means that standard ACL starts from 1 to 99. So this is IP standard access list. So if it was an extended, it would have been 100 to 199. So since it is a standard, I'm going to say access list 10, and then now is to deny, either deny or accept. So I'm going to deny this network here. I'm going to deny this one. Yes. So I'm going to deny this one and accept this one, which is permit. So to deny, I put this command deny, and then now the network IP address. So 192.168.2.0, and then now the wildcard mask, because this is OSPF. This is access control list. Access control list and OSPF use as wildcard mask. So yes, so 0000. So this is /26, which means that it's 192. So it's 255 minus 192, which when I calculate, it is 63. Okay, so this is 6 and 3. Perfect. So the next one is also I'll permit the next network. So permit, this network is .3 network. So it's the 3 network, and it has the same subnet mask. So it's also going to have the same wildcard mask. So there we go. So what I'm going to do is to allow this access control list inbound on the serial interface. So to allow this access control list into the serial interface of R1, I'm going to have the command interface as 0/1/0, and then now it is IP group. Oh, IP group. Yeah, I think I'm doing okay. Oh no, it's access group. Oh yeah, perfect. So 10, since it's the access list of standard, and then it is inbound. Perfect. So there we are. Exit. So I'm going to show the access lists which are there. So to show IP access list. So the access list which are here is 10 and then 20. So in the 10 access list, it's going to, because the router itself will have to line these up. So if there were many, maybe deny others will be here 30, 40, 50. So but here there are only 10 and then 20. So the first one is deny the 192.168.2 network, and then permit this other network. So to see the practicality of this, what I'm going to do is to ping R1 from R3. So from here, R3 here, I am going to ping the other one. And to do that, I'm going to ping from this PC, and then you see. So from this PC, say I want to ping from this PC to this other PC over here. So it is going to allow me to ping, but it's not going to allow this other network because this one was allowed and was permitted. So let's check it out. So ping 192.168.1.2, was it 2? I think it was 2. Yes, it is reachable. Perfect. So if I try pinging this from here to the other one, ping 192.168.1.2, exactly, it is unreachable. Destination host is unreachable. So if I want to know, like, and trace the route as to how this one got to be like that, what I'm going to do is to trace RT and then 192.168.1.2. Yes. Yeah, so like as you can see here, it can reach to its default gateway, which is this one, the 192.168.2.1, and then it can also reach to the next router, which is router 1, but it cannot reach this other place here. Yes, because it has been denied from here. Yeah. So yes, so that's the end of this video, and thank you very much for watching. Yes, thank you. Bye.